All right, so we are given an angle alpha in quadrant 3, and we're given an angle beta in quadrant 2. So we're given two angles in this question, and we know what cos of alpha is, and we know what sine of beta is, and we want to determine the exact value of sine alpha plus beta. So there's a lot of information here. I have a name for these kind of questions. I call these questions double triangle questions. Da, 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 da. There we go. So I call them double triangle questions because you are going to draw a triangle for alpha and a triangle for beta because we're given two different angles. So what do we know about alpha? We know it's in quadrant 3. So in these double triangle questions, there will always be enough information for you to tell where, in which quadrant the angle is in. This is the easiest one because it's really obvious because it tells you in quadrant 3. Sometimes they'll tell you cos of alpha is -3/5 and tan of alpha is bigger than 0. So that would also tell you it's in quadrant 3 using the cast rule, but it would be a little bit harder. So in quadrant 3, you draw your triangle with your reference angle. There's our reference angle for alpha. And we know cos, which is adjacent over hypotenuse, makes this 3/5. A squared plus b squared equals c squared. And you could calculate that this is going to be 4. Draw our beta triangle right underneath. Beta was told to be in quadrant 2. So we can draw our beta reference angle. We know that sine is 1/3. And a squared plus b squared equals c squared will give us √8 for the other side. Now, the reason we draw both triangles is once we've drawn both triangles, well, we already knew that cos of alpha was equal to -3/5. We now know that sine of alpha is equal to -4/5. Because it's in quadrant 3, sine would be negative as well. And here with beta, we knew that sine of beta was equal to 1/3. We know now that cos of beta is -√8/3 because it's in quadrant 2. Now the question's asking us to determine the exact value of sine alpha plus beta. On our formula sheet and up on the wall over there, we know that sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. And now that we've drawn both of our triangles, we have values for all of those. So the important thing to realize for this next step, do you know what alpha is? No. But you do know what sine of alpha is. I don't know what alpha is, but I know what sine of alpha is. So the entire sine of alpha gets replaced with -4/5. So you don't write sine of -4/5 because you don't know what alpha is. You just write the -4/5. And you don't write cos of -√8/3 because you don't know what beta is. But you do know that cos is -√8/3. You know what cos of alpha is. Cos of alpha is -3/5. And you know that sine of beta is 1/3. These are non-calculator questions because if you multiply these, you will get 4√8/15 plus a -3/15. And those already have a common denominator. So you get 4√8 minus 3 all over 15. So again, the most common mistake is in this next step right here, that students write another sine, another cos. Okay, you don't need to write that down because you know what those angles are. The other common mistake is people don't use the formula. The only way you can expand sine alpha minus beta is to use the formula. You cannot write that this is equal to sine alpha plus sine beta. And you can't plug numbers into here because we don't know what alpha is and we don't know what beta is. You could find them if you were allowed your calculator, but this is a non-calculator question. Okay, questions you can do that are like this one, number 8 and number 13, and I'll give you some time to try those now.